Hello, everybody. My name is Madhuri. I am the founder of Ilotal, makers of Nodeless Kubernetes. Prior to that, I've been a systems engineer for 20 years, worked on Flocker, which some of you might remember from the early container ecosystem days, where we helped run stateful applications inside containers. And prior to that, worked on resource management for VMware Stack, on initial placement load balancing of virtual machines in a VMware cluster, and also VMware's hypervisor product. Prior to that, worked on Oracle database server technologies in clusterware software, so mostly systems and distributed systems engineering. How many of you use Kubernetes currently with Prometheus? Wow, awesome. Um, Kubernetes capacity planning on public cloud is super hard. When you take a regular Kubernetes cluster, instead of focusing on your applications, your pods, your resource manifest, you as the DevOps and SRE folks spend a lot of time on hand curating the worker nodes. You have to select the base worker node type and what price point of the worker node you want to select, whether it's on-demand, preemptive, spot, or Fargate kind of compute launch types. And also you have to hand curate the auto-scaling knobs and maintain, monitor, and update the auto-scaling knobs based on your application's workload changes. And also when a worker node dies, it is a pet worker node, so you have to, someone has to be on on-call rotation to make sure that the compute capacity is still enough to run your worker nodes. The compute capacity on public cloud is ephemeral, and it doesn't have the same static, sticky qualities of server blades on on-premise data centers. So why are we continuing to manage and provision compute on public cloud as if we own the machines sitting in a private data center? So if we over-provision the compute capacity nodes, we are wasting resources, we are wasting money. If we under-provision, the pods will be in pending state and won't have the compute node available when it wants to run. And unexpected spikes during rolling upgrades and horizontal pod auto-scaling will be very lazy to react. Nodeless Kubernetes is a flavor of Kubernetes, which basically makes sure that you consume public cloud capacity as and when it is needed for your Kubernetes clusters and focus on your Kubernetes applications instead of focusing on managing the operational complexity of your Kubernetes cluster worker nodes. So what Nodeless Kubernetes does is that the control plane looks down and sees a worker node which advertises very large capacity. It advertises, let's say, 1024 vCPUs, 4 terabytes of RAM, tens of GPU devices, and it says that I can run up to 1,000 pods. But in actuality, it is the virtual capacity of the cloud provider that it is advertising. It's not pre-provisioned, always-on worker node that is advertising this capacity. So when a pod is provisioned to this worker node, the worker node will provision just in time, right-sized, cost-optimized compute launch type for the pod on the cloud provider that you've configured. And the just-in-time compute is started up and the pod is dispatched over to the compute node. As long as the pod is running, the pod appears to be running on the large virtual worker node. And once the pod terminates, the underlying compute capacity is automatically terminated. The compute launch type could be sourced from all the different flavors of launch types that are available on your cloud provider. So it could be an on-demand compute node, it could be a spot instance, it could be a Fargate launch type, or it could be a newer, better, cheaper launch type that the cloud provider has brought to market 3 months from now. So you don't have to keep like a hand-curated list of the various compute launch types that are available. So one of the questions that we get asked quite a lot is that, hey, how do we manage Nodeless Kubernetes applications? Does Prometheus work with Nodeless Kubernetes? And the short answer is yes, it works with Nodeless Kubernetes just like it works with a regular Kubernetes cluster. So there is absolutely no change from the user point of view. And this is a question that gets asked most often when we talk about Nodeless Kubernetes. So let's go ahead and see a demo of how this is going to work. So out here, I have a single master, single virtual worker node cluster that is a nodeless worker. So we have single control plane node and a single virtual worker node. Let's describe node on the virtual worker node. So if we look at the capacity of the virtual worker node, it's saying that it has 1024 vCPUs, it has 4 terabytes of RAM, it has 10 GPU devices, and it can run up to 1K pods. So let's actually look at this host name in our AWS console. It's actually running on a T2 medium instance, which has 2 vCPUs and 4 gigs of RAM. So the worker node actually has very little capacity, but it's advertising 1024 vCPUs, 4 terabytes of RAM. So as the first workload, let's go ahead and deploy our Prometheus stack. Sorry. So we are trying to create Prometheus stack with Grafana, Cube State Metrics, and Prometheus deployment. So we have services associated with Grafana, Cube State Metrics, and Prometheus. And I chose to externally expose all these 3 services for demo purposes. And we have deployments associated with, again, Grafana, Cube State Metrics, and Prometheus. And we have the 3 replica sets corresponding to Grafana, Cube State Metrics, and Prometheus. So all of these 3 components are being deployed into monitoring namespace. So what is happening under the covers is that in our single node cluster, the 3 deployment requests enter the Kubernetes control plane. The control plane looks down and sees just this one worker node, which has this very large capacity. So it schedules all three pods onto the virtual worker node, and virtual worker node will make the call as to what is the right compute launch type that fits the resource requirements for each of these pods, and a just-in-time compute launch type is provisioned, and each pod is scheduled to the just-in-time provision compute launch type. As of now, Nodeless Kubernetes can only run stateless applications. So what it does is there is an admission webhook that will dispatch the stateless applications in a nodeless fashion, and the stateful apps are started up on the virtual worker node's compute node itself. Support for stateful apps will be coming in a couple of months. So this is a temporary dispatching hybrid model that is being implemented right now. So what will happen now is that the control plane is going to start the Prometheus deployment on the worker node itself, and just-in-time compute cells, nodeless cells are provisioned to run Cube State Metrics and Grafana. So let's see if our pods are running. All the pods are running. So let's try to access our Grafana dashboard. It typically takes a little longer time for the external load balancer to be available. So let's see if that is up and running right now. All right, so let's go ahead and add a data source for Prometheus. since all the three components are running in the same cluster, I don't need to use the external IP, so I will use the service address for internal communication. And there is a very simple Grafana dashboard for monitoring nodeless cells. So let's go ahead and import that dashboard. So what this dashboard shows is there are 4 columns. So the first column is the number of nodes in the cluster, which is 2. We have 1 control plane node and 1 virtual worker node. And the second column is components that are running on control plane. So control plane node name and the number of pods that are running on the control plane. It's mostly the control plane components, API server, kubeproxy, etc. And the third column is the worker node components. There are 7 pods that are running on the worker node itself, including Prometheus deployment, because it's a stateful application. It's running on the worker node itself. And the interesting column is the 4th column, which lists the nodeless compute cells that are running in the system. So there are 3 nodeless compute cells. They correspond to Grafana, kube state metrics, and kubeproxy, which is a system pod that we can ignore for the purpose of this demo. So as if we want to create an Nginx deployment, for example, which is stateless to start with, let's look at the Nginx deployment, which is asking for 3 replicas, and it doesn't have any persistent volume needs. Once we create this deployment, once the pods are up and running, because the control plane is going to schedule the Nginx pods on nodeless cells, because they don't have any persistent volume needs. Once the 3 nodeless cells are up and running and the pods are dispatched over to the nodeless cells, the Grafana dashboard should reflect that our nodeless compute cell count should go up from 3 to 6 eventually. I'm going to pause here for questions. This is the gist of the demo. The key takeaways are that if you're using Kubernetes on public cloud, not having to hand curate and babysit these pet worker nodes is a cleaner way to consume public cloud compute capacity. And Prometheus and Grafana are the perfect fit for monitoring nodeless Kubernetes applications, and there is no difference in monitoring nodeless Kubernetes applications versus your regular vanilla Kubernetes applications. So if you want to give this a try, I'm going to share the GitHub location for running this tutorial yourself. Thank you so much, and look forward to the questions.
Yep. Yes.
Hi, thanks for the talk. As this is more a talk about Nodeless, I just wonder how you do all the affinity and anti-affinity stuff, as the scheduler doesn't know how to work with it.
Right, so with Nodeless, you get 1 pod per compute node isolation, so you get anti-affinity out of the box.
And affinity?
Affinity, there can be an admission controller which schedules if pod A and pod B have an affinity rule, they become 1 nodeless pod. So they will be scheduled as 1 nodeless pod, basically. So they'll collocate on the same compute node. Does that answer your question?
It does.
Mm-hmm.
Doesn't understand why, but
Questions? Are the AMIs that are running on the nodes, are those special nodeless ones or just the bare bone ones that we would run for EKS, for example?
Yeah, so that's a good question. So one of the motivations for Nodeless is to eliminate the need for maintaining the operating system, the security patches and all of that overhead. So by default, the Nodeless cells run an Alpine base image, but some enterprises have pre-listed blessed images that they want to consume instead of Alpine, so you can override that AMI. By default, it's an Alpine AMI. So the key idea is to keep the system overhead of the cell, to keep it pretty minimal, so that you get majority of the resources in the cell for your application.
Thank you very much.
Anyone else?
Hi, great talk. So what is the latency of provisioning the actual compute nodes? Because we're advertising a lot of compute, but we don't have it exactly.
Right.
What is the latency? And as a follow-up, if you're not able to provision that compute, what would happen?
Yeah, that's a good question. So the compute launch type latency varies between cloud providers, and even on a single cloud provider, it varies between the various launch types. So for example, on demand on AWS can take anywhere between 5 seconds up to 2 minutes, whereas Fargate can launch really quickly. So there is a knob that you can turn on in a Nodeless Kubernetes cluster where you specify the SLA, and depending on the SLA for your application startup, if your app has a 5-second SLA between kubectl create and the app responding, then the Nodeless engine will maintain a set of pre-warmed cells that are pre-booted so that your SLA is honored. So it's more of an SLA-driven capacity management rather than having to provision it beforehand. Does that make sense?
Hi. If you configure a daemon set to have one node exporter running on each node, what happens in this nodeless scenario with that?
Yeah, so that's a good question. So daemon sets are
Ow, my back.
So daemon sets are came into existence with the assumption that you have these very large server blades that are comprising of your worker nodes. So the idea of the daemon set is to collect all of, to represent the compute nodes agent, correct? So that is what we are trying to achieve. So what you can still run a daemon set on the virtual worker node itself, but it will run on the virtual worker node. It won't run on every single cell. So depending on the motivation for your daemon set, you can have, for example, you can run elastic beats, file beat, or node beat, etc. If it is something super lightweight, then it can be injected into the cell itself. So it totally depends on what is the purpose that your daemon set is trying to address. Does that make sense? If you have a specific use case, I'd love to chat afterwards.
Just a second.
Question similar direction. What about running a custom ingress controller on this infrastructure? Basically, same problem as with the daemon set,
Right.
but also regarding networking. So do you have some extra hops in it then?
No, so one of the key design goals of Nodeless is for the behavior for networking and storage and everything else to be exactly the same as regular Kubernetes cluster. So we, in fact, there's a blog post that talks about how Istio would work. So your sidecars are still running on the cells. They're not running on the virtual worker node. So each cell, all the networking sidecars will run on the compute cell where your pod is running. So it works just like your vanilla Kubernetes, basically.
Okay, thanks.
Anyone else? Thank you.
Thank you.